welcome to another coding session where I'm creating a new programming language from scratch. The language is called Plum and it kind of looks like, like this. So you have types, you can define functions. Last week we started with implementing error handling, so that an invalid program doesn't crash the compiler, but that the compiler instead ends with a hopefully helpful error message that tells you where something went wrong. And the way that works is that we have this file that contains the definition of an error. An error has a message, which is just a string, and it has a source, which is a location in the source code. Currently, the compiler can only compile one file, and this source just contains, the range in the file. These are like byte offsets in this string. Right. So, like most compilers, the Plum compiler is organized into stages, which are these. And they are named after breakfast ingredients, and the names don't really matter. The important thing is that we go from each stage to the next one. The bacon is, for example, a very abstract representation of the indentation of the file, basically. The toast is a parsed version where your code is basically a tree. Then that gets converted into more like a graph thing, and then we add types and type checking and so on. And finally it gets converted into C source code. Actually at this stage, right here, there can be no error, because the type checking, it succeeded, and from yogurt to C, we don't need to do any error handling. But for the other stages, we do. Last week, we implemented error handling from bacon to toast, which basically means that in the compiler, there were some panic calls or unwraps and so on, things that can crash if the input is invalid. And we replaced them with basically creating an error and returning that. So most of the functions that convert bacon into toast, these are called parse something, they now return a result instead of just a value. And that basically means that it may succeed, then it returns a toast, or it may fail, then it returns an error. Now we basically want to do the same thing, but for the next compiler stage, which means when converting the toast to the egg, we also want to replace the panics with, returning an error. So let's just see where there are panics in here. Okay, so there are some panics, where we have a type called int, and you use it with type parameters, and that doesn't work because int is a built-in type that doesn't take any arguments. We do something. If you reference a name that doesn't exist, you call some function, but it doesn't, there is no function with that name. Or type with that name. I think we're at the type level right here. Again, wrong number of arguments. Seems like a common error. Then down here we look up visible variables. So basically resolving names and calling invalid things and having an empty body where we expect body. I'm not sure if this can actually occur. Let's see. So we have we converted toast to egg. And I think in the toast, toast.body, toast, what is it? Expo for expression. Toast expression.body with some children exists 3 times. First time it's called with children. Yeah, okay. That may be empty. Sure. So we need to catch that error here as well. Okay. Cool. Yeah, let's just do that, I guess. But in order to create errors here, we also need the source. And that means that at some point in the toast data structure that represents our program, we need to add sources so that we know, for example, where an expression comes from. I think it's actually best to do that on the expression level, just because that's the most consistent. For example, if you call something that is not a name, that doesn't work right now. So, for example, in your code, if you do something like, I don't know, we call the 5 with hi, this shouldn't work. And the source will basically be the place in the source code where the error is attached to. And I think here we just want to underline the 5, for example. But this can be anything. This can be a string, this can be any expression. So let's just say that the receiver here will have a source. Which means in here, every toast expression needs a source. Which means let's maybe switch this in, like split this up into a toast expression, which has a source and it has source and an expression kind maybe. And we name this to toast expression kind, maybe. Yeah, I think that's fine. Cool. Yeah. That means that we now need to, like, each time we create a toast expression in here, we need to instead, like, we need to create that, sure, but we also need to associate the expression with a source. And okay, only 14 places. Okay, that's fine. We can deal with that. Okay, parsing an expression that doesn't include white space. That's called an atom, and here we parse those. So if there's an opening parenthesis, we parse some expression after that consume a closing parenthesis. And here you see an example of how we return errors instead of crashing the compiler. Right, the parser, if we see it has this function source of rest. And I think we just need to, we need a way to, I don't know, consume things. I think parseInt should just return an int, and that's it. But let's look, maybe, yeah, let's look inside of parseInt. Here. Okay, so the character should be a digit, and it advances the cursor and so on. So the parser cursor is actually the thing that tells us where did this source code come from. So maybe for the parser, let's add another method similar to source of rest. Yeah, let's also add, I don't know, source of, maybe? And then you can pass in cursors, which is just range, and it returns a source. Maybe that should work. So that would just take the input source of the parser and then modify its range. Like, return a new range, return a new source with another range, where we basically take the cursor range start, which will be the, the cursor inside of this input, and we need to add the start of the input source range. So input source dot start. Yeah. And yeah, basically the same thing with the end, I think. Just hang on, no, input source dot start plus cursor range dot end. Yeah. So then in here we can just save, start is parser.cursor, and then in here, in here the source is actually just parser.source of, and then start to the current thing, so parser.cursor. Oh, okay. Actually, you know what? I think this doesn't work. No, sure. I think, hang on, what is the error here? Oh, it also needs to take a parser. Hang on, source of, yeah, that needs a parser, like this. Beautiful. Yeah, input source needs to be parser.input source. And same here. Okay. Oh, right. Range.start. Damn. Maybe save that into a temporary variable. Like this. Beautiful. Okay, yeah. I like this. Then, okay, so I think a very common pattern will be taking the source from, some start cursor to the current cursor. So something like source from until, or like source until cursor from weird name, very weird name. Yeah, and this will be start to cursor. Source from until cursor. Still weird name. Like the from is something you provide and the cursor is the end. Can we what's a better name for that? I'm not sure. I guess this is fine. So toast expression.int, toast expression kind.int, Oh yeah, and then we need to wrap that in a toast. You know what? That's so common. We'll add an operator for that actually. So creating a new toast expression. I think an add is fitting. Yeah, because an add is like, you know, like a location. So this will take the toast expression kind and the source, and it will return the toast expression with that kind and source. So you can just write toast expression kind.int, add this source, and you get a toast expression. And let's actually do that down here. So toast expression kind this, add this location, please. Boom. Yeah. And here we'll use the from until cursor thing. Hang on, what's the... Yeah, it is a bit shorter. Okay. It is more verbose than before, definitely. But I think for, you know, being able to associate each node in the toast with source information, that's fine. It's fine. Yeah, toast. You know what? Let me just. Yeah, toast expression dot something will be toast expression kind. Yeah, just renamed every occurrence in this file. So we'll actually get, you know, like type errors or something, telling us that they need to be associated with, yeah, this can't be a call, it needs to have a location. A location, right. So here we pass an atom, which will be, hang on, that will be a full toast expression. How's atom? Yeah, that will be a toast expression. And that means that we can that means that we can just get the source from that, right? So we can say parser dot source of. Hang on. Now let's just take the source directly. Input source with range, and then basically expression dot source dot start. Yeah, like this. To something. To like the call goes from the start of the first you know, the start of the first expression till the end of the last argument. So yeah, expression dot args dot last. Yeah, I think there needs to be an argument. Yeah, calls always have at least one argument, because in this language, like, it's a completely functional language. If you would have, like, functions can't have side effects. So if you call something with 0 arguments, that's just a variable. Yeah, last is a function that returns something. Oh, it immediately returns, interesting, something like this, perhaps. Yeah, goes from the start of the, like, callee, receiver, however you put that. Oh yeah, here we also check that the args are not empty. So args.last always works. Okay. Next, down here. Yeah, this is not an enum, that is true. It has a kind, and that kind is an enum. And of course we need to associate those with source locations. So the toast call that exists. The question is, what is its source? And I think we'll also just take the left thing, you know, like parser input source with range, left.source.range.start and piped into source.range.end, something like this. Yeah. Oh, right. Ooh, interesting. Let's just take the source of the left the left thing then, I guess. Yeah, and extend that into the source of the right one. This call doesn't work with range. Oh, right. Yeah, because these should be range. Does it make sense to just, you know, merge two sources? Take the minimum start and the maximum end. I think that makes sense. And that better reflects the... It's not like the left source is somehow prioritized in this case, you know. It's just happens to be there. And also the... like, what did we... There was something that we changed very recently. I think the call, piped call. We'll find that. Yeah, so let's just add that in the error file. I want to be able to, I don't know, union two sources maybe? I don't know how to call it. Or just AND two sources. Why not? We have A, which is a source, we have B, which is a source, that returns a new source. We should make sure that this is the case. We don't want to compare the file content of the this is the entire input. Comparing that is inefficient. Yeah. So then what we do is we take the range. Hang on. We create a new range basically. Yeah. Where the file content is just, I don't know, a.file content, I guess. And the range is a, like the minimum of a.range.start and b.range.start until max of a.range.end and b.range.end. Perfect. Okay. Yeah, we can combine sources. So then in here we can just say, you know, left.source and right.source. Huh. So much easier, like so much shorter. I'm not sure if AND is the correct thing. This is already used for, creating a range. Could do this. Oh, but that's weird. No, let's stick with AND for now, and then, yeah. We can change that later on, if we want to. To be honest, I'm fine with that. Okay. Yeah. With range, I'm just gonna look for that, because I think there was some cases where that was kind of weird. Unpiped expression. Ah, yeah, this. Here we take the source from the expression, and the source of the last argument. Boom. Combine them to give us a source that spans the entire call. Yeah, that's cool. And what else is there? There is this. To toast type def. Okay, throws some error. I mean, sure. I'm fine with that. Oh, hang on. Although we can simplify that. Yeah, we can say first child dot source and like we know which one of these will be smaller than the other, but I think it's still more elegant. Sauce and bacon. These definitions have the same name, but arguments don't match. Huh. Yeah, true. This should have a dot source. The more I'm writing this, the less I am convinced that the AND is a nice operator for that. Because it is like a range, But the double dot is already used for creating ranges, which makes total sense. So let's just use the triple dot, maybe. Yeah. And then let's also just use this, because I think we're always certain which is the previous, like the start and what is the end. Yeah, like this. Perfect. Hell yeah. Okay. Now we're talking. So, yeah, this should be left.kind. This is something. Here we have an invalid assign because we need a source for that. And we have a variable with an expression and a value. And I guess the source would just be expression to the value, like the source of those combined. Very cool. Oh, sorry. Yeah, the sources combined, like this. Then creating a variable, very similar, I suppose. Yeah, that will just be expression dot source to children dot last dot source, perhaps. But the children can be empty, right? I think they can be. create var. What is that? Yeah, this also makes sources. Okay, if there's an equals sign but no children afterwards. What do we do then? What do we do? I think we just invent a child, I guess. You know, you can always do that. So I guess if children is empty, then we'll just invent a child, because why not? We need to do that anyways, you know, I think. Do we? We don't have a source for the children. That's kind of bad. Yeah, children source. And I think we can just check if the children, you know, if they are empty, then this is just the equals source. Otherwise it's children.last.source. And then we can use that source both in here otherwise it's children.first.source yeah, until children.last.source. Yeah, kind of like this. Ugh. Kind of a mouthful, but sure. Yeah, and the children will just be the children source, and these right here will be, well, they will also have a source, which is children not empty. Then we will just use the children source, like expression source until children source. Oh, yeah, let's do this then. Sure. Oh, maybe not. Sure. And call this body source, because here the children become the body, and it makes more sense, like semantically. If there is no body, then the equals sign is kind of like the body. Yeah, if the children are not empty, then we just take the source of the last child, and that is it. In here, toast expression kind. Right. But where are we? We are in parse switch, right? Where we pass this percent sign, makes sense. And then we want to pass a switch case where we pass parameters, sure, a colon, and then a body. Okay, so if there is nothing coming afterwards, yeah, then we just say, okay, there is no child in here. let's just use the children. So let's just, let's only pass the children that must succeed. And as for our source, we will just take the source of those children, I guess. Yeah, so first child until last child. And the question again is, well, what if there are no children? And I think then this is an empty body, that should be fine. Then we will use the colon. So here we get a colon source, and then in here we will just say the body source, well, we have our children in here, and if our children are empty, then this is just the colon source. Otherwise it's children dot first dot source until children dot last dot source. Amazing. Okay, here this is just the children at the body source. Cool. Very, very cool. The last expression of the function body doesn't match the return value because it's a toast expression kind. Indeed. Indeed. This should be something at some source. Okay, so the bacon line should just be a percent sign, the entire line. So we'll just take the bacon source in that case. So everything from the percent sign until, I guess, the last case, right? The last of these cases. And again, the question is, what if there are no cases? Well, edge cases over edge cases. So I guess if there are no cases, then this will just be, that may actually be valid. I hate that. Yeah, because if you have an enum with no variance, for example, like a never type function that never returns, and we switch on that, maybe that's a thing. I'm not sure. Yeah, but we'll just choose the bacon, like the percent sign source. Otherwise, we'll take the source of the last child, which will be cases.last. Hang on, that's a toast case, and toast case has a body, very nice. Body, and the body has a source. Whew, cool. Now down here, this is a toast expression kind instead of a toast expression because we need a body. And again, what if there are no children? The age-old question. And I guess we will just take the child, or we'll just take the equals sign as the child. Yeah. Body. The body source is, if oh, amazing. So if the children are empty, then we'll just take the equals source here. Otherwise, we will take the source of the first child until the last child. Okay. Nice. Wait, no error. That's... I'm suspicious. Like here should be errors for sure. Yeah, because we switch on the entire expression instead of on its kind. So here, those expression, no, the kind is what we want. Yeah, I think that's it, basically. Let's see if this works. Oh, hang on, I'm gonna go full screen. Plum. So, let's just compile this, which means we will use the compiler of my previous language to compile the compiler of this language and run that. I should zoom out a little bit. Yeah, let's make this clearer like this. Yes. Okay, assembling, and this is what we get. The program panicked. Oh shit, what is this? Welcome to the Plum compiler called non-name something. Oh yeah, that is this. Cool. So apparently the first part of that worked. Our toast now contains sources. Where's that again? Here. Our toast expression now contains a source. Very, very cool. So let's use that source when we convert the source, the toast to egg. Because each panic in here, we now have the information we need to attribute that to a particular place in the code. Yeah. So converting a toast to an egg doesn't work all the time. It may fail. So this returns a result. Fair enough. Yeah. And I mean, in almost every case, it actually returns. It actually succeeds. So that's like, you know, the default. So let's just wrap the entire body in an OK. Yeah, and then if it doesn't work like in this panic, then we will instead return an error. So here we return an error, ID error. Yeah. Unnamed reference name something. Oh yeah, and this needs an error. So let's create an error. An error, I think, needs a string. Oh yeah, it also needs the source, which we don't have yet. Yeah, that should just be the toast source, right? Does that work? This work? I think it does. The error, yeah, takes the string, takes the source. Amazing. Beautiful. What about this? This doesn't work. Well, that kind of sucks. Because returns, this returns a result now, which means, like, we call ourselves recursively. If that doesn't work, we want to immediately return the error. Correct. Egg switch. Try to assign result to field condition. Oh, yeah, the condition can also fail. Like every case, to egg basically needs to be behind, we need to unwrap that, or like bubble up the arrow, if there is one. Okay, invalid assign, this is why. Okay, and up here, let's guess, we probably call to act exactly. Oh. Yeah, this needs to work, and that means that this function actually also needs to return a result. Oh yes, converting toast to egg can fail. We have these definitions, and in the in the end, we say, okay, this worked. Here's your egg. But if this fails, for example, then we just return the error. Okay, amazing. That was kind of short, actually. Condense the code. Dense code is amazing. Okay, let's compile that. Ooh. To yogurt. Oh, I know. So in the main file, Yeah. Look at this. So converting the bacon to toast, for example, can fail, which means that we need to catch the error. Well, the same thing can happen when we convert the toast to an egg. Then we also need to print the error. So panic. Okay, so there are some panics in here, right? Oh yeah, lots of panics actually. Okay, let's replace them one by one. Oh, to egg doesn't return a plum type. No, it returns a result because it may fail. And yeah, okay, the entire thing is just wrapped in okay. Let's see here. Like this. Amazing. Honestly. Pretty cool. Yeah, arc to egg can also fail. Oh. Yes. You only do early returns in here. Here we have this. Here we have this. Yeah, okay. Let's maybe inline this into the individual switch cases. I think that's more yeah, it gives you a better overview in this case. So yeah, for the enum, we wrap that in an OK. In here we do this, right? Yeah. Yeah. And then for call, we also wrap the individual things in OK. Amazing. Wait, this doesn't work. Because this type can also be an error. Oh, error handling is amazing. Okay. This may fail. Up here, these may fail. Oh yes. Let's guess the return type. Yeah. Okay, nice. And now we can actually replace the panics with errors. So here we just return an error from type error. Oh, hang on. Nope, we can't do that yet. Well, that kind of sucks. because our toast, while our toast expressions contain their source, toast types do not. Well. But for the expressions, at least, we can do that. So there's, here's a panic. I think that's actually the panic that that happens in our thing. Clown type. Oh, clown egg ID. Yeah, that's more like it. We return that. Okay, and that needs an error. True. So we need to pass in a source, and that will just be call receiver.source. Amazing. Okay. Body cannot be empty. We should have handled that. Yeah, I think the more elegant way would be to handle that in the in the toast, because there we have so many like extra handling for empty, like you don't have any children. Ooh, yeah, this for no, hang on. Yeah, this exactly this. So if children's empty, blah 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 blah. But what we really want is to just say, hey, the children, like, there's no body here. So let's just return an error. Hang on, let this helper function bad input with an error that just says expected a body, and then we can, in good conscience, I think, use the equals sign to show the error. Okay, that's super nice. Yeah. So we have this, and then the body source will just be children dot first dot source to children, which again is not super convenient, but at least I guess it's better than now. Let's factor this out. Yeah, it's better than doing that in the next stage, like basically ignoring the error here and fabricating source and then raising an error later on. Right. So there was, we did that in a couple of places. Yeah, here as well. If there is no, this will fail in the next stage. So we will actually need to make sure that there are definitely children. So if children is empty, that's actually an error. Then we need to return an error. We need to return bad input of toast expression. Hang on, let me just copy that. I don't know, expected the body of the case, because we're in a switch case. Something like this, perhaps. And let's just take the colon source. Sure. And the body source will then just be this. Amazing. Cool. Oh. Yeah, okay, that's an error. Fine. Hang on. Yeah, if bacon children is empty, then something. Otherwise, if they are not empty, oh yeah, okay, they may be commons or something, you know, so that these children are empty. Ooh, okay. Oops. So let's maybe, you know, the body source is something. It's just equals source. What is that? Like, and if children dot is empty, then equals source, as else children not first dot source. Yeah, if they are empty, that's an error. Then we want to return an error that just says, hey, this is a bad input. You don't get any toast fine. Expected. Is it function? Yeah, I think we're passing a function right now, so we need to give us a function body. Otherwise, we take these. Okay, this call doesn't work because it expects an error. Sure. Var body source something. Okay, I guess. Nice. Yeah, let's just compile it. Oh, we don't get a stack trace now. That's good. Instead, we get, oh no, an error occurred. And that's something that we wrote. So in here, oh no, an error occurred, and then the error. The error is kind of shit. Yeah, this one right here called non-name, and then, oh, I see, that contains the source again. Yeah, makes sense. Yeah, let's instead just say that something like you can only call names. Okay, you can only call names. Well, the location is kind of, you know, not perfect. Why is that? I was expecting a little, like, snippet of the source code above that. So let's just print the error line index. Error in line. Error in line 0. Really? That is unfortunate. And the egg. Okay, maybe let's just print the toast, you know? Yeah, let's print the toast. And here, let's print the toast. Oh, that doesn't work right. Oh no. And the toast right stuff up here. We need to use the kind. Yeah, like this. Okay, now we don't print the source. Yeah. So let's do that maybe, or at least let's do that for the, like for numbers maybe, because that's the thing that's relevant right now for understanding the error. So add expression.source, maybe something like this. Yeah, no, that's nonsense. I think they're all like relative to the start of the line or something, and not of the entire file. So that would suggest that when parsing something, we attach here source from until cursor, and then we parse in the start. With range. Oh no. No, we want something like this. Well, you can just say source off, and then a cursor range, which goes from start until the current cursor. Yeah. Yes, this is a nice error. Error in line 310, and then we have this nice thing you can only call names, and this is underlined. Amazing, honestly. Okay, yeah, very, very cool. So let's, what should we do? Let's just remove the toast printing here, because apparently that works right now. And let's go on to the next stage. So converting egg to yogurt. Oh yeah, there can definitely fail things in here. Like, we don't find a function or something like that. Oh yeah. So that's maybe, what do we need to do here? I think we just need to have the same approach. Actually, I think you should be able to just call lookup, and yeah, that doesn't need I think the wherever you call this lookup function is where you actually want to, you know, wherever you call this, you actually have the context of what should the source be. You have the call, for example. So I think this should just return a result, not of error, but of string. And then we can just do, you know, return an error in here that says, hey, it's nice that you want to call a function, but there is no function with that name. And same here, we can just return an error. There is no matching function named something, whatever that means. Oh, I see. I mean, we should print the partial matches in here, I guess, but the quality of the errors, you know, they can be greatly improved. For now, I just want to get some errors at all. Like, yeah, and down here we just return an OK. Amazing. Okay. Yeah. Here, main lookup. Yeah, this, for example, like, what is the source? What do we underline in your file if you don't have a main function? I don't know. I really don't know. Should you even see that in your IDE? Maybe. I don't know. Yeah, let's just say or return error. And for the source, I'm actually just gonna choose an invalid source for now. Yeah. Okay. Yeah. This is not a variant of blah blah blah. Yeah, because this may fail. Which means that this entire to_yogurt of this egg expression can also fail. Oh, look at this. Amazing. Oh, but we can't just do this. It has the wrong type. Yeah. Because this is a result string and we need a result error. So, if there is an error, and so that's like an error message, then we want to return error from this function. And that's like an error of the error. Oh god. Yeah, it also needs a source, and that will just be the source of the call. Oh, look at that. We need sources in the yogurt as well, which makes total sense. But that means that the what was it? Toast? Sorry, egg. The egg also needs sources. Egg. Egg fun has name, params, return type, impl, egg fun impl, which can either be a built-in function or like an actual function with egg expressions. Yeah, I'm very afraid. Yeah, we need to do the exact same thing. The exact same thing for... No. For the sources. Oh no, hang on. Hang on. Oh yeah. Here the egg code contains a slice of expressions. And the egg body, like everything just uses egg IDs, Yeah, I guess that's better, maybe? Maybe. So egg expression has a kind, which is an egg expression kind, and it has a source. And the kind says which kind of expression it is. And just like with the toast, we also have an operator. And I think it makes sense to use the same @ operator for that. Yeah, comparing egg IDs. Sure, let's do that here. No, let's put that first. So this is an egg expression kind, and the source gives us an egg expression. Sure. And now, when we create an egg expression, like here, push param, we need to know where does the parameter come from. So we need the source for that. Makes sense, to be honest. How many occurrences are there? Do I want to know? 56. Oh god. Sure. Number 1. Here we already have an egg. Let's just follow the arrows and see where that leads us. Yeah, push param doesn't work. We need to know the sources of the parameters. Well, of the function parameters, actually. Do we even have them? I don't think so. Like, you know, param. Oh, maybe we don't know. Param.name, param.source, not toast param. Ooh, okay, so toast params have a name, have a type, and they have a source. Sure. Okay. That is nice. Now the question is, yeah, where do we, like, oh, here's probably an error, right? Yeah, down here. Here we have the source. The source will be what? It will just be the name is parse name. Yeah. Yeah, okay, I think parse name can actually return both a string and a source. Yeah. Do I want to refactor them? Maybe I do. Yeah, sure, let's refactor the... Yeah, let's refactor this. Okay, so, I think, yeah, let's just create a new string and source, something like that. Yeah. Just contains a string and a source. And yeah, parse string. For now, let's leave that like this. Maybe later, maybe it does make sense to put that into the leaf functions and no. Okay, parsing an identifier will just be this identifier and the source. Alright, and we have start and end. We have that here. Amazing. So the source will just be parser.input source. And parser.source of start to end. Yes. This call doesn't work. Okay. Oh, string and source. Yeah, you should be able to do that. Let's add a function here. Takes a string, takes a source, returns something inferred, which is a string and source of string and source. And then in here, parse a symbol. The last expression returns something else. Yes, indeed, it returns a string and source. That's good. Same here. And what about down here? Parse name. Oh yeah, so params are just string and source. That they should be that. Oh, to toast type def. Yeah, okay, maybe like right now we don't need them, but I think later on it actually makes sense to have them. And for now, let's just take the string here. Like later on, for example, if you define a type and two of the type parameters have the same name, or two function parameters have the same name, we also want to highlight them. It basically makes sense to put all the calculation of where is the source, push that into the leaf parser functions like parse name, parse int, parse string, and those other functions then aggregate sources or discard them if they don't need them. But yeah, we will improve that over time. Like over time we will carry more and more source information for basically every node of the toast type. Right, so we have a toast type call. Oh yeah, with a name and arguments, and the name, you know what, I think the name should actually be a string and source, right? Hell yeah. So let's move this further up, because now it's not like a simple helper data structure. No, this is actually like part of this up here. What is it? Toast call? Toast. Symbol. Oh yeah. You will need this. Like we want to be able to underline symbols in a case like this. Like the type that you switch on doesn't even have this symbol. We want to then we want to like highlight that symbol. Toast variable. Not sure for now. Let's just leave that as a string. Ooh. Does it make does it make sense to have sources only in the leaf nodes of this toast expression tree? And if we need sources for errors or something, we can always like aggregate them into something more higher level. But then again, yeah, let's just leave it as it is. I'm not sure about that, so I don't want to prematurely refactor things. Just get it to work first, and then those little API fringes of how do we design things, they settle over time, I think. Try to assign string and source to a field name of type string. Oh, toast type call. What even is that? Oh, toast type call up here. String. And type. Sure. Then again. And this is kind of language dependent, you know. This language is mostly white space delimited. If, for example, the call had parentheses around it, it would probably make sense to have that as a separate thing, you know. Like have the source of the entire call and then also the sources of the arguments and the name and so on. So in the long term, I want the toast to be very close to the existing source code as well. So I think let's just but currently it doesn't. Like, for example, a pipe. A pipe just becomes a call. And that means that for some calls, the receiver will be further, further in the beginning of the line than the rest of the toast. I think the real solution for that would be to to make it so that this is really suitable for formatting. So have nodes in here for parenthesized expressions. Have nodes in here for pipes versus normal calls. Yeah, maybe not parenthesized expressions if they are like formatted in a deterministic way, but calls, yeah. Yeah, okay. Okay. I'm fine with that. So for now, let's keep that here, but let's add a to do. As we move this tree, the toast, closer to the original source code, such as, when we represent pipes differently. Okay. In the long term, we should move the toast closer to the original source code. For example, by representing pipes and calls differently. This then allows us to use the toast for formatting. Yeah, and once we have that, we can adjust the description up here. Then we should be able to not have separate, or to not save the source in every tree node, but only in the leaf, only in the leaves. Okay, yeah, that's the the long-term plan for this file. For now, we have way more important things to worry about. So, yeah. So toast type.variable, string and source, but it needs a string. Sure, let's just, I'm fine with that. Let's just give it a string. Variance.put, this call doesn't work. Oh, it expects, guess what? A name and pass symbol. Wait, this should be string or something. Oh yeah, that's correct actually. String and source. Like this. Oh, but to Bacon type, the types themselves, do they have I guess in a type definition? That also makes sense. Yeah, let's just save this in here. Okay, we can use this, long-term thing of only saving the source in the leaves. Let's try to use that for type definitions, just so we kind of dabble with that architecture and see where things might go wrong. Yeah. So just have it like this. Basically every string gets converted into string and source, and the only remaining things are enums and like the structure of the types. Okay, right. So here we have toast type.variable. I'm trying to create toast type.variable with a string, but it needs a string and source. Right. Fixed. There is no error. String and source needs to implement a hash. Oh yeah. String and source, string and source, hashes. Oh wait, it needs like a hasher, yeah. And it basically just does, I don't know, hasher.hash the string and the source. Okay, sure. Oh wait, the source has the entire file inside. Let's just do this. Cool. Cool. Entry.key equals key. This call doesn't work. Yeah, comparing them. True. Oh man. So we have a string and source, and we have another string and source. Are they the same? Well, it depends. A.string equals b.string. Kind of like this. Oh yeah, and sources. Let's just compare the ranges, I guess. For now. Wait, why are they in maps? That's the better question. Yeah, this should not be. This should be a list of enum cases, I guess. Toast type enum case. We have toast case, so that's just type case, I don't know. It has a name and it has args. Look at that, very, very similar. A list of toast type cases. Okay, yeah, and then we don't need these. Because you shouldn't, like, compare them. You shouldn't. They should only be used for being transformed into some more abstract representation. And that's it. You should never compare string and source. You may compare the strings inside, you know, or put those into a map or something. But this entire thing, no. Okay, so where does this fail now? Hasher. Okay, why does it try to hash them? To toast type, put the thing, oh yeah, right, in the functions here. So here we create a map with the variants, and I think this should be a list of toast type cases. And then for each variant, we do stuff, and then we put something in here. And by the way, before this was broken, actually. Like this could have overwritten something that was already inside. It's good that we don't do that, that we just represent them as a list. This should represent, this toast should be able to represent any source code, even if it contains errors. Well, my camera died, but that's fine. So we are pushing the toast type case here with a name and args. Perfect. And name is string and source. Amazing. So then in here, try to assign slice string to the params. Params are up here, string. Let's turn that into string and source and just remove this part. Because why not? Very cool. Down here. This call doesn't work. This is the signature, right? String builder, blah blah blah. Okay. Why do we want to? Oh, yeah. Okay, fair. Type of param name. True. Ooh, and yes. Here we just want to print the source, right? And I mean here as well, why not? Type of param. Amazing. Toast param. Let me look for the toast param. Toast param. Oh, I mean we could just say string and source. I think that's the better thing to do. And then we can just remove that and instead do this. Perfect. And up here, oh yes. Yeah, passing a name means that in here we create a name which will just be that. Add the name source. Boom. Here we'll take, yeah, similar. The symbol, add the symbol string, add the symbol source. Great. And then down here, params should be a list of string and source. Toast fun. Name. Yeah, let's turn name into a string and source. Great. That's pretty cool. Okay. We're done with the toast. Let's look at the egg. So get maybe. Yeah, that doesn't. Oh, what is that? Oh yeah, this should be the type string. Sure. Oh, right. Yep. Well, this is like the an if-is pattern, where you have one single binding for that. Could it? Yeah, sure. Oh, yes. Oh, look at this. We can just return an error. Damn. Return error, toast, I don't know, toast type. Sorry, plum type. Error. 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 Yeah. Come in with args, and we can attribute that to this. Amazing. Like seriously, this is great. Empty or boom, called string. Does that fit on the same line? Oh, almost. Oh, enough for me. Good enough. It called type, sure. Type, and then here we have never. Called never with args. Fantastic. This call doesn't work. Okay, up here. Oh yeah, because this should only compare the strings. Sure. Then down here, for call and parent calls, oh yeah, call name is this one. And the args are the same, then stuff is bad. Otherwise, yeah, we don't want to compare them. We want to compare the underlying strings. And like this, string and source is a wonderful example of a type that you don't want to be able to compare. Even though it's like implementing comparing would be pretty trivial. Yeah, that's, yeah, this returns an error. Type error, and the error is try-to-grade name dot string, perhaps, or is it just that? Maybe just that. But it needs this many arguments, sure. And then the source of that is the name. We do something very similar down here, where we just return this. Fantastic. Yeah, expected closing parenthesis, hang on. Oh yeah, there's a mismatch. What's going on here? Writing string and source. Right, so this should be the string. Yeah. This call doesn't work, okay, because we're putting in the string of that. Yeah, name should just be named of string. Okay. Okay, value is not a field on this case. It only contains these fields. Value. What? box. Oh, I see. Because this was, this was a map before, and we had map entries, and now these are the args. Much more descriptive. Yeah, this is the name, the variant name, and we actually put the underlying string of that into this thing. And here we should also check for duplicates. Yeah. Then up here, param. Now param doesn't have a source, but its name has a source. And this, of course, defines the string. Wonderful, wonderful. Okay, add expression kind, and we wanted to do something very similar with just, hang on, can we just do toast.source? Yeah, that just works. Oh, we should do that everywhere, right? Oh man. Oh, hang on, the param takes a source, right? Yeah, it takes a source. Well, for each of these params, and I think it's just param.source or something. Yeah. And this should also take the string there. Wonderful. Wonderful. This call doesn't work because the symbol, the important thing is the string. Here we have a body. This call doesn't work. This is the signature, blah, 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 blah. And we need to associate that with the toast source. Same here, I think. Yeah, that entire thing is either a call or the creation of a tag. And then up here, try to assign string and source to field name of type string. Oh. Yeah, sure. For now, let's just do that. And then later on, maybe the yogurt needs some strings or more sources. We can add them. We'll see. Yeah, here we are in the yogurt. And things fail because we need to switch on the underlying kind. The kind. Which kind of expression is it? So there's not a field on egg call. True. So the call itself, hang on, it isn't. Egg call. Oh yeah, it has a receiver, and that receiver then has a source, right? That's where we want to highlight that error. Maybe it doesn't. No, that receiver is just a string. Hang on. No. Egg call. Where are you? Egg call. Receiver is just a string. Now we want to be able to call the receiver source. Oh yeah, and there will be errors here somewhere when we create the egg call. Receiver will be, well, I guess receiver at toast source. Cool. Long, but fine. Okay, here we want the only the actual name. Yeah, that can fail. In which case, yeah, receiver source seems fine. Here we take result function to yogurt. Hang on. We call something. If that doesn't exist, no, we want to show an error at the function name. Like here, for example. And by the way, this is something that I dislike about, for example, how Rust handles errors. If there's a type error in, I don't know, some function argument or something, the entire function is underlined. Like if this is a function across multiple lines, you have, I don't know, assume this entire thing is underlined. If you're like down there somewhere and it's like just all red, that doesn't tell you anything. But if you instead just underline the function name, that's like very obvious, very in your nose, I think. Then you can say, hey, this function doesn't match any function. Well, anyways. Okay, so we have this, and this is the signature. Okay, ECFun, fair enough, fair enough. String and source. That should probably be just the string. Same here. And then up here, the last expression doesn't match the return type. Okay, this returns a result. Does it do anything? I don't think so. Nope, it doesn't. Which means we need to wrap this entire switch in an OK. Okay, guess what? This can fail, probably. Which means that this can fail, which makes total sense. Which means that this needs to be wrapped in an OK. Oops. Like this. Okay, and down here we have another call which doesn't work, which will just be because the body is result. So it should be like this. Body.returns is not a variant because body can fail. Of course. Hang on, not allowed in a function. Yeah. 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 Result. Amazing. Here we say, sure, we have a cached function. Everything is fine. Everything is awesome. Everything is cool. Part of a team, okay. Yeah. Boom, 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 boom. Last expression doesn't match. Okay, so let's fix that. Let's just say yogurt. What was it? Yogurt. Oh, yogurt. Oh, we're already at the top level thing of the yogurt. So then the only remaining thing is this. Adding error handling for the top level. And compiling this to C actually always works. Always. Okay. Yeah, true. Now let's change that. Rearrange that and just remove that. And maybe okay, like in general things compile. But for example, we can also do this. We can say, well, this returns an 8. And it doesn't really. But now instead of the compiler just panicking, damn it, it panics. Okay, right, because in the yogurt, we still have panics, right? Oh yes, we do. Oh yes, we do. Well, for the function, what do we want to underline here? We have the eggfun. I think just the function name, perhaps. Yeah. Eggfun.name. Or that source? I'm not sure. Oh, eggfun name. Okay, so eggfun. Let's turn that into a string and source. We could also underline the entire return type. Is that cool? Maybe. But for now, we don't need to have perfect error reporting. Just do something. Yeah, for the built-in, or create a built-in function. Those, I guess invalid source. Yeah. What about up here? Oh no, just take the name immediately. Like this. Great. If fun.name string equals name, then we do stuff. Oh yeah. Name.string for the matches. Cool. Yeah, let's look for other panics. Body, params, len doesn't match. What is that even? Oh, but that's like an internal thing, right? Doesn't match number of param types. Params.len equals body.params.len. Yeah, that's an internal compiler error actually. Like, we should panic in that case. Yeah, and here we should just return. Oh, I don't even know. Return Gilbert expression, error of the error, switched on non-enum, and then look at source location, which will just be the the expression source, maybe. That would basically underline the entire switch. Exactly what I don't like about the Rust approach. I only want to underline the keyword or the important part, this nugget that goes wrong. But I guess I can do that later. So yeah, here we should also return errors of an error of something. And the source of these should just be the expression source for now, I guess. Yeah. Oh, wait. Here, for this switch case. Amazing. Wait, isn't case.key like... Oh, it's a map, actually. Well, okay, then. Like, if this was still, you know, string and source, we could just underline the exact switch case. But never mind. Yeah, I couldn't join types. Ooh. Yeah. Oh, still inside a switch. Yeah, and we just underline the entire switch, which, I mean, I guess. Ooh, interesting. Got a type that's not comp time. Oh. Yeah, for now let's just panic here. But this is definitely something that we need to change. Okay, so here we have casts. Compile cast. Funny body. Yeah, I think that should return an error as well. Yeah, but for now let's maybe not do that. Yeah, and let's instead just say, okay, we panic in that case. Sure. I just want to see the compiler complaining about, oh, look at this. Damn, return types don't match. Claimed type int, actual type string, and you get a nice, like, the context of that error is this function. Cool. Again, the concrete type, we have lots and lots and lots of more places where we can better handle invalid code and be more robust in both the parser and the following stages. For example, switch with multiple cases with the same name, we should handle that. And we also want to improve the error messages and so on. But for now, I'm just happy that we get something that works, and that the compiler doesn't just panic for invalid programs. Like, of course, it still does for some of them, but for the vast majority, that should work. Okay, I'm gonna take a break, and then, well, we'll see what we'll do then. Well, as usual, the break was a bit longer than expected. So I think I'm just gonna replace the true remaining panics in here, and then we'll call it a night. Right, so there were 3 panics in this file. This one is expected. Hang on, is there a typo? Yeah. Doesn't match the number of parent types, right. And this down here, we replace these, which means that this right here will also return a result of yogurt ID and an arrow like this. And instead of this, we can just return an error. Error of yogurt ID and error with an error. Oh, hang on, no, with a string basically. Yeah. This is supposed to be a string up here. And then this will be an OK. Of that. And same here. Same here. Okay, and then this entire thing is also supposed to be a result, which means that we just wrap everything, and I mean everything, in an OK. Nice. Yeah, I like that. Right, up here we have the yogurt fun with the yogurt body, and of course returns is this. True. This doesn't work because our surrounding function must return a result. This and a string, I think. Then this works. Almost. Now it works. And then up here, where we actually have the, the built-in call. Oh, I see. Yeah, the question is, what is, this doesn't work because it expects an error. Because currently our assumption is if you compile a function, and that may produce an error, but it's always an error of the function itself, and not of the person who called this function, which is usually true because the person that calls this function, this function was chosen because the type signature matches and all that good stuff. So we actually know that the call matches this function signature. That's why this function is being compiled right now. So it's difficult to assign blame to the caller. Yeah, so instead let's just say the error is kind of that's difficult. I would say inside of a built-in, basically, but that doesn't really make any sense. For now, let's just return an invalid source, and then that should work. Hang on. Case built-in. Yes, the wrong type. That's what I'm trying to fix. Yeah. This will just return an error. Easy. And this would then also need to return an error. Ordered. At some point we need to create the error. I think I'll just create the error here. If there's an error, then we just return an error of yogurt fun error, and recreate it using the error message and an invalid source. Sure. Yeah, question mark has the wrong type. You used question mark on a result where the error type doesn't match the error type of the function. Oh yeah, right. Like this. Okay. Very, very cool. Okay, yeah, so now basically you can compile any program and it is guaranteed that this won't panic. Yes, there are panics in here, but okay, one is inside of the .plum file. There's this, but this is more like a compiler assertion. If this panic is reached, then toToast is used in a weird way. That this is the compiler's fault. And same here. This should always be the case. And oh, what about this? Casting. Compile cast fun body. Yeah, we only have valid casts in this stage. Yeah. So this as well. This will never be reached. which means right now you should be able to write anything in this file. And no matter what you write in here, the compiler will not crash. The compiler will maybe produce, like a nice error message that tells you, hey, right here you do something wrong, blah blah blah, and then the actual message. Yeah, but it won't crash anymore. And I guess that's a nice achievement. And I'm just gonna stop today because it's after midnight, and yeah, I guess see you next week.